Hello everyone, welcome to today's movie. In today's movie we're going to look at the chi-squared test for proportions where we got the independent case, and we're going to use Excel in this movie to solve this problem. And in another movie we'll look at the use of SPSS. So let's go to Excel, and this is example 8.3 data set from the textbook, and you'll see in this case that we have some data which has been collected which looks at whether or not people travel on a bus to work or don't travel on a bus to work on 2 days, a Wednesday and a Saturday. And what we're looking for is to see whether or not we have a difference in the proportions of travel to work on Wednesday compared to Saturday on the bus. So we got the data. We can see on Wednesday there was 105 travelled on the bus to work, on Saturday it was 90. On Wednesday, 70 didn't travel on the bus to work, but 100 did. So we can see here that we have 195 people who travelled on the bus on the Wednesday or the Saturday, and we have 170 who did not travel on the bus on the Wednesday or the Saturday, and we have 175 on a Wednesday in total, 190 on a Saturday in total, so it gives us a grand total of 365. So what we can do is we can because we got a frequency count, we have to use the chi-squared test of association or independence. So step one is to state the hypothesis. The null hypothesis is that there's no difference in proportions exist. The alternative hypothesis we're going to take is that there's a difference between the proportions. Step two is select your test. Now we're going to use chi-squared test of association because we've got a category data variables, we have frequency counts. Step 3 is select the level of significance, and again we're going to choose 5%, which is 0.05, but that's your choice. Step 4 now is to extract the relevant statistics. So before we do that, obviously we need to know what the expected frequencies are when we got independence. So you can see here that I've put the equations down. You can see there's a general table for a 2x2 contingency or crosstab table. The overall proportion is given by this equation here. And if independent, then the expected frequencies are given by this equation, just like any other chi-squared crosstab table calculation. So we can see here that for this cell, the expected frequency there would be the row total, which is E6, times the column total, which is C8, divided by the grand total, which is in E8. So you can see that comes out to be 93.5. So this value here, which is in the not bus, would be the row total 170 times 175, which is the column total for that cell, divided through by the total, which is 365, and then repeat it for Saturday. Now remember that we use the chi-squared test of association, so there's our chi-squared equation there. So we compare the observed and the expected frequencies, so we have to calculate this ratio for each cell. So you can see here, look, that for this cell, which is observed is 105, the expected is 93.5, square the difference, then divide through by 93.5 to give us 1.416, and repeat that for each of the other cells as well to give you those numbers. Okay, so we look at this, extract the relevant statistics, then we use this equation to give you the overall proportion for the bus. Then we can calculate by summing these numbers what the chi-squared test statistic is, which comes out to be 5.841, using this equation here. So we summed all the values. Now we need to know the number of rows. Well, we got 2 rows and we've got 2 columns, and we can calculate those values either by inputting as 2 or use M8EXCEL function. Okay. And then the number of degrees of freedom is that minus 1 multiplied to give you 1, using that equation there. Then we can then calculate what the p-value is, and we can use the chi-square.dis.rt Excel function to calculate the p-value is 0.016. And I've used 2 alternative ways of writing that to get the same answer. So the p-value is 0.016, which is less than 0.05. So we reject the null hypothesis and we accept the alternative hypothesis, which states that there is a difference between the two proportions who travel on bus on a Wednesday compared to a Saturday. Okay, right. And alternatively, if you want to use the critical chi-squared value, then you can. And you can calculate the critical chi-squared value using the chi-squared.inv.rt Excel function. If you do that, it comes out to be 3.841. And you can see that our calculated value is greater than the critical value, so it's in the right-hand tail. So again, you would reject the null hypothesis and you would accept the alternative hypothesis. Now, you could also apply Yates continuity correction to that number there. And all that means is that you just have to modify these numbers here using the Yates continuity correction. So you can see here that I've taken the absolute value of the difference between the observed minus the expected, and I've subtracted 0.5, then I've squared, then I've divided through by the expected. Exactly the same as when you do a normal crosstab contingency table chi-squared calculation. And if you do that, the Yates continuity correction chi-squared value is 5.345. The p-value is 0.02, which is still less, obviously, than the significance level of 0.05. So again, you would reject the null hypothesis and accept the alternative hypothesis. So a significant association does exist between the two. Okay, a significant difference does exist between the two. And again, you can calculate the chi-squared critical value as well. Okay, so using Excel to undertake chi-squared is a little bit tricky, but it hasn't got that many steps in the solution process. Okay, so you could also, if you wanted to, do a Z approximation using these equations here. And if you do that, you'll find you get exactly the same solutions. Okay, so this solution is in the book. Okay, so you've got the chi-squared normal test, you've got a Yates correction method, and you've got a Z-test approximation, which is in the book. Okay, bye for now. In the next movie, we'll look at SPSS solution to this problem.